Hi everyone, today we're going to go through some most commonly tested PSLE science heat application questions. Firstly, we're going to go through about expansion and contraction at the basic level, and then we're going to go to expansion and contraction at the advanced level, and then we're going to look at rate of heat transfer. Firstly, let's take a look at expansion and contraction. Here is our first sample question. First we'll be going through sample questions, then after that we'll give it a try at exercise questions and we'll go through the answer afterwards. Here's the first question. Why are there gaps between the sections of the railway? The gaps between the track provide spaces for the track to expand during hot days. This prevents the track from buckling. I have highlighted the keywords in red. They are to provide space and to expand during hot days. It's really important to mention about room or space that is given and expansion or contraction that takes place. The one which is highlighted in yellow, preventing the tracks from buckling, is unique to each question. You have to apply your common knowledge to the context of the question. In this case, it's for the gaps between the sections of the railway, and this prevents the tracks from buckling. Here is the next sample question. How are pipes carrying hot or cold liquids adapted to their function? Pipes carrying hot or cold liquids have curved joints or are coiled. These curved joints provide some space for the pipes to expand or contract to prevent them from breaking easily. Here we have stated providing some space, and we have talked about the expansion or contraction as highlighted in red. The part highlighted in yellow is unique to each case, and in this case is to prevent them from breaking easily. Here is your first exercise question. Why are bottles/cans not filled completely? Take a look at the diagram and try to answer it on your own. Pause the video now. Bottles and drink cans are usually not completely filled to allow room for the liquid to expand, so as to prevent the bottles and cans from breaking or bursting. The part highlighted in red, instead of giving space, in this case is to give room. And we have spoke about the expansion or contraction as well. In this case it's expansion. And the highlighted part is unique to each question, and for this question is to prevent the bottles and cans from breaking or bursting, because if there's too much liquid then the can will break or burst. Let's move on to the next question. Why are overhead telephone lines/cables hung loosely? How about you give this question a try on your own? Take a look at the diagram. Pause the video now. Overhead telephone wires are hung loosely to allow them to contract during cold days, preventing them from snapping. So we have talked about giving them space to contract and contraction or expansion occurring. And the highlighted part is unique, and we have mentioned that as well. And in this case is to prevent them from snapping. Here is another point to note down. These cables cannot be hung too loosely as they will expand and sag during hot days, making them hazardous. Here is a more challenging question for you guys. How do bimetallic strips and fire alarms work? The bimetallic strip is the one in yellow and gray in the diagram below, and here's a diagram of a fire alarm. Here's a hint. Have you took a look at the hint? If so, do pause the video and work out your answer in a piece of paper. Metal A is a better conductor of heat than iron, thus it expands and contracts faster than iron. The different rates of expansion and contraction of the two metals can close or open the circuit. So metal A is the yellow part and iron is the gray part, and iron expands more slowly and while metal A expands more quickly than iron, so it causes the bimetallic strip to bend and touch the nail, causing the fire alarm to work. Over here we have spoke about which is a better conductor of heat. In such challenging questions, it's important to emphasize all the important points, such as the rates of heat conductivity of different materials. And as usual, we have spoke about the different rates of about the expansion and contraction of the materials. And the yellow part is subjective to the question. Here is the next challenging question. How are wheels placed in metal tires? Here's a hint. Have you taken a look at the hint? Then attempt this question on your own. Pause the video now. Metal tires are heated and expanded before they are fixed onto the wooden wheel to ensure a tight fit. The tire is made slightly smaller in diameter than the wheel. When the tire loses heat and contracts, it makes a tight fit on the wheel. Here, I have highlighted some important points. The yellow part is subjective to the question, and it helps to explain the question further in this case. We have to mention the tire being heated and expanded, because the expansion plays a major role in explaining why the tire is heated. When the tire loses heat and contracts, the tire losing heat and contraction, the rate of heat loss and contraction is important to be mentioned as well. Let's move on to the second part. Expansion and contraction, application of expansion and contraction to experiments. Here is our first example, is the ring and the ball experiment. You may be familiar with this before, but let's just take a look at it and familiarize ourselves with it. Before the metal ball is heated, it can pass through the metal ring. After the metal ball is heated, it cannot pass through the metal ring. This is because, here's an explanation for this. This shows that the metal ball expanded upon heating. So when it expands upon heating, it becomes larger in size and it's unable to pass through the metal ring. After the metal ball has cooled, it can pass through the metal ring. This shows that the metal ball contracted upon cooling. When the metal ball contracts, it becomes smaller in size and it's able to pass through the metal ring again. Here's the second question. Take a look at the diagram first. Are you ready? The water level drops when the colored water is heated initially. This is because the flask expands before the colored water does, so the volume of the flask increases, creating more space for the colored water to occupy. Some of you guys must have been confused by this question. Let me explain it. So, since the flask is closer to the heat source than the liquid inside, it expands before the liquid in it expands. Thus, it becomes larger in size and it's able to hold more water, thus the water level decreases. After heat is applied for a while, the water level increases. This shows that the colored water expands when it's heated. Unlike the first question, the flask has already been heating for quite an amount of time, so both the flask and the water would have expanded, but since it's being continually heated, the water is expanding greater now, and thus there's a higher water level because it expands and occupies more space. After cooling for 20 minutes, the water level decreases to the initial water level. This shows that the colored water contracts when it's cooled. The colored water contracts and occupies lesser space, causing a drop in the water level. Here's the third example. Take a look at the diagram. Air bubbles are seen forming in the beaker of water when the flask is heated. This shows that the air in the flask expands when it's heated. The expansion of air causes the air to occupy more space and increase in volume. So some of the air is forced out of the flask as air bubbles. Water level. Let's take a look at setup B. Water level in the glass tube increases when the cloth at 0 degrees Celsius is placed on the flask. This shows that the air in the flask contracts when it's cooled. The contraction of the air causes the volume of the air in the flask to decrease, creating more space for water to be drawn into the glass tube. Here's the fourth example. Take a look at the image. Setup A is the one with the red color balloon and the hot water, just for clarification. The balloon inflates when the bottle is placed into the basin of hot water. This shows that air expands when heated. Air in the bottle gains heat from the hot water and expands. The volume of air increases and occupies more space, causing the balloon to inflate. Setup B is the one with the yellow balloon and the cold water. The balloon deflates when the bottle is placed into a basin of cold water. This shows that air contracts when cooled. Air in the bottle loses heat to the cold water and contracts. Hence, the volume of air decreases and occupies less space, causing the balloon to deflate. Here is the fifth example. This may actually be very useful for real life as well. You may find yourself using this method if your ping pong ball is dented. The dented ping pong ball returns to its original shape when it's placed into the basin of hot water. Air in the ping pong ball gains heat from the hot water and expands. The expansion of air causes air to occupy more space and increase in volume, so it pushes the ping pong ball back to its original shape. Here is the sixth example. Take a look at the diagram. Setup A. The drop of red-colored water moves upwards when both hands are wrapped around the test tube, and the test tube gains heat from the warmth of the hands and it expands. This causes its volume to increase, pushing the drop of red-colored water upwards. The drop of red-colored water moves downwards when the test tube is immersed into a beaker of ice water. Air in the test tube loses heat to the ice water and it contracts. This causes its volume to decrease, so the drop of red-colored water moves down to occupy the space. Let's move on to the third part. Rate of heat transfer. We're going to be taking a look at the types of conductors, the exposed surface area, and the color and texture of objects. Good conductors of heat are materials that allow heat to flow through easily. Generally, metals are good conductors of heat. Poor conductors of heat are materials that do not allow heat to flow through easily. Air and non-metals such as plastic and wood are poor conductors of heat. In cup A or B, would the water reach room temperature faster? Explain your answer. Cup A. Steel is a better conductor of heat than plastic. Hence, as compared to the plastic spoon, the steel spoon would conduct heat from the hot water to the surroundings at a faster rate. Therefore, the water in cup A would lose heat faster and reach room temperature faster. Whenever you're explaining such types of questions, it's always important to state, like comparison questions, it's always important to state about which material is a better conductor of heat and where it's conducting heat from and where it's conducting heat to, and whether it's at a faster rate or a slower rate. I have made the keywords in red color so that it's easier to view. How about you try this next example by yourself? Which of these materials, A, B, or C, is the most suitable for storing ice cream? Explain your answer. Take a look at the diagram and answer the question. Pause the video. Let's take a look at the answer. Material A. This is because the wax on this material took the longest time to melt. It took 75 minutes. And due to this, the wood took the longest time to fall off, showing that it's the poorest conductor of heat, conducting heat from the flame to the wax at the slowest rate. Over here we have mentioned our keywords about which is a poorer conductor of heat, the comparison of the conductors of heat, and from where it's conducting heat from, and at what rate. Hence, material A can be used to keep ice cream cold for a longer period of time. For the longest period of time, sorry. Let's move on. Surface area of the object. Greater surface area. The greater the contact/exposed surface area of an object with the heat source/surroundings, the faster the rate of heat transfer. The lesser the surface area, the lesser the contact/surface exposed surface area of an object with the heat source/surroundings, the slower the rate of heat transfer. Let's take a look at a question. In which metal pot, A or B, would the water boil first? Explain your answer. Metal pot A, as compared to metal pot B, it has a larger surface area in contact with the heating plates. As you can see, this is because of the empty spaces in the heating plate of metal pot B. Hence, heat from the heating plates will be transferred to the water in metal pot A at a faster rate. Always remember that if the water has higher temperature, then heat is transferred from the water to the surroundings. If the water has lower temperature, heat is transferred from the surroundings to the water. This applies to any other question. This allows the water in metal pot A to gain heat faster and boil first. I have highlighted the keywords in red about the surface area and contact, from where to where the heat is transferred from, and at what rate, and the conclusion. These are some important points to mention no matter what question it is. How about you try this yourself? Elephants keep their bodies cool by losing heat from their ears. Which elephant will lose more heat? Explain your answer. The Asian elephant or the African elephant? Take a look at the diagram. Pause the video. Let's take a look at the answer. The African elephant. It has larger ears as compared to the Indian elephant. As compared to the Asian elephant. Hence, as compared to the Asian elephant, the African elephant's ears have a larger exposed surface area, which allows it to lose heat from its body to its surroundings at a faster rate. Over here, we have spoke about the surface area, the comparison of the surface area, from where to where it's losing heat, and at what rate. These are the important keywords that I've highlighted in this question as well as in the previous questions. One fun fact is that African elephants have larger ears to lose more heat because they live in a dry and hot climate compared to Asian elephants. The color and texture of objects. Black, dull, and rough surfaces absorb more heat, while shiny, white, and smooth surfaces absorb less heat and reflect heat at a faster rate. Let's take a look at a question. Alice placed two tins, P and Q, in an open field on a sunny day. The starting temperatures for both the tins were the same. She then measured and recorded the temperature of air in each tin at 10-minute intervals over a period of 30 minutes. Take a look at the diagram below. Pause the video and try to answer the question. Here's the question. After 30 minutes, the temperature of air in tin Q was higher. Explain why. Tin Q has a black dull and dull surface, it absorbs heat from the warmer surroundings and conducts heat to the air in the tin at a faster rate. As a result, the temperature of air in tin Q is higher than tin P after 30 minutes. As we have seen in the previous slide, black and dull surfaces absorb more heat, so we have to state that fact, and we have to state at what rate. Part B. Aluminum foil is often used to wrap chocolate bars. Based on the experiment, explain why aluminum foils are used. Aluminum foil has a shiny surface that reflects light and heat. Therefore, the aluminum foil would absorb less heat, and less heat would be conducted from the aluminum foil to the chocolate. As such, the chocolate would not melt easily. Over here, I have bolded the keywords in red as well. It's important to mention about the shiny surface that reflects light and heat, and the rate of absorption of heat. How about you try this yourself? Penguins live in extremely cold weather and their backs are usually black. Suggest why having a black back would be advantageous to the survival of penguins. The penguin's black back absorbs more heat from the sun. Thus, it would keep the penguin warm in extremely cold weather. In the previous slide about the introduction of color and texture of objects and how it affects heat, we learned that black surfaces absorb more heat. Thus, we are able to understand this question more easily. And it's important to mention about the rate of absorption of heat and explaining that it keeps the penguin warm, because that's the main answer of this question. Hope you enjoyed this video. Thank you so much. If you have any questions, feel